What happens when a force of 140 Newton is applied to a set of blocks of mass 10, 20 and 40 kg respectively on a frictionless surface? Anyone can answer this. It will move. In more precise words, as per Newton's second law of motion, it will accelerate. Each of the blocks move with acceleration. Acceleration comes because of the net force, and so then following questions arises. What is the net force on each block? And what about the action-reaction pairs between the blocks? Same questions for other situations. Situations like when the blocks pressed against a wall with the same force, or when you stack those against the gravity. And what about changing the sequence of stacking blocks? Let's check out the net force on each block and interacting action-reaction pairs between the blocks in each of these cases. Case 1. When the blocks are pushed by the force and accelerating. Accelerated motion keeps the blocks together, interacting with each other with normal contact forces. Is each block here experiencing the same net force? One thing we know for sure is all the blocks are together and moving with the same acceleration. Acceleration of system of block of total mass of 70 kg. As per Newton's second law of motion, it comes out 2 meters per second square, and each of the block is moving with the same acceleration. But the blocks are of different masses. So even for the same acceleration as per Newton's second law of motion, each block will be experiencing a different net external force. For example, here the net external force on block A is given by mass of that block, which is 10 kg, multiplied by its acceleration. So net force on block A is 20 Newton. Similarly, we can find out the net external force on block B and C. Now, it is important to note that the sum of these net external forces on the blocks is equal to the total net external forces on the 3-block system. The other way to find the net force on any block, we need to look for all the external forces working on that. Here, since there is no motion in vertical direction, so vertical forces are balanced and the net effect is 0. Let's check out the horizontal forces on each block. On block A, there are two forces, applied force of 140 Newton and a contact normal force by the block B. As per Newton's third law of motion, block A applies an equal and opposite force on block B. This action-reaction force pair between block A and B is Newton's third law force pair. Similarly, there is action-reaction force pair between block B and C. Now let's analyze the motion of individual block to find out the action-reaction pairs. A block of mass 10 kg accelerating with 2 meters per second square under the influence of net force. The net force on A is equal to 20 Newton as we have already measured. This is also equal to the difference between two horizontal forces of 140 Newton and the normal force on block A. By using this information, we get the action-reaction force pair between block A and block B. Similarly, difference between horizontal external forces on B gives net horizontal force working on that. We have already measured the net force on B by using Newton's second law of motion. By putting values of net force on B and FBA, we will get the value of force on B by C. And this is same as force on C because of block B. Both of these forces are Newton's action-reaction pair. Now, let's check out the case 2. When 3 blocks pressed against a wall with the same force of 140 Newton. What will be the action-reaction between each block pair? Let's consider forces working on block A. A force of 140 Newton working in positive x direction. Now since block is at rest under this force, there must be an equal and opposite force in negative x direction. This force is provided by a normal contact force by block B. Block B will experience a force of 140 Newton in positive x direction as a reaction force by block A. And since the block is at rest under this force, there must be an equal and opposite force in negative x direction. This force is provided by a normal contact force FBC, force on B by block C. By now you might have recognized that FAB and FBA are action-reaction force pair in between block A and B. And both of these blocks are at rest as there is no net force acting on these. Similarly, block C is at rest under two equal and opposite forces working on that by the block B and the wall. The interactive force of 140 Newton between block B and C is the force pair between these blocks. So we saw that in case when a set of three blocks pressed against a wall, action-reaction force between different pair of blocks or block and wall are same. And since all the blocks are at rest, net force on each of the block is 0. Case 3. What will be the action-reaction between each block when the blocks in case 1 is stacked? Each block has its own weight because of gravity pull by the earth. If we talk about interaction between block A and B, block A apply a normal downward force on block B because of its weight. And as a reaction, block B apply a normal upward force on block A. It is important to note that both of these forces are normal force in nature, equal and opposite, and work on different objects, block A and block B, and so makes a Newton's third law force pair. What about the interaction between block B and C? There is a downward normal force on block C because of combined weight of stacked block A and B. That is 30 kg force or 294 Newton. As a reaction, block C apply an equal and opposite upward normal force of 294 Newton on block B and creates an action-reaction force pair. Similarly, you can explain the action-reaction force pair between block C and the ground. Here all the individual blocks are at rest as there is no net force on any of the block. Let's see each block for the net force. Block A, gravity pulls of 10 kg force is balanced by a normal force by block B on A and keeps the block A at rest. What about block B? A normal downward force by block A of 10 kg force plus gravity pull on B of 20 kg force is counterbalanced by a normal upward reaction force by block C on block B. In case of block C, normal downward force by block B of 30 kg force, because it is a stack of block A and B combined together, plus gravitational pull on C of 40 kg force is counterbalanced by normal upward reaction force by the ground on block C. Because of these balanced forces, the net force on each block is 0 and the blocks are at rest. Now, here is a question for you to answer. If you create a reverse stack of blocks with a 140 Newton downward force on block C, what is the net force on each block and what are the action-reaction pairs between the blocks? Put your answers and valuable comments in comment box below. I hope you would have enjoyed this session. If you think you have learned something new today, then please don't forget to click like button and subscribe us for similar type of new video every week. Thank you for watching. See you next time. Bye.